So homework 28 is solving radical equations. So on example 1, we have square root of 3a plus 10, all of it's underneath the square root, equals 7. So the very first step is to get the radical isolated or all by itself, which the square root of 3a plus 10 is already isolated. So now we have to square both sides. So I'm going to square this side of the equal sign, and I'm going to square this side of the equal sign. And so when you square a square root, the square root when you square a square root, the square root goes away and you're left with 3a plus 10 equals, and then I've got my 7 squared, so equals 49. Then I solve, just like I always have. So I need to subtract 10 on both sides of the equal sign. So I have 3a equals 39. Divide by 3, divide by 3. A equals 13. Okay, problem 2 is square root of 3x plus 19 equals 7. So I have the radical isolated. So I'm going to square each side of the equal sign. So when I do that, the square root box goes away, and I'm just left with 3x plus 19 equals, and then 7 squared is 49. And I'm going to solve minus 19 on both sides of the equal sign. So 3x equals, and then 49 minus 19 is 30. Divide by 3, divide by 3, x equals 10. And that's our answer. Okay, the difference in number 3 is that I have the square root of x, and that's the only thing under the square root. Then minus 9 equals 7. So because the square root just has the x, it's not currently isolated. So to isolate it, I need to do plus 9 on both sides of the equal sign. So the square root of x equals 7 plus 9, which is 16. And now that I have the radical isolated, I will square both sides of the equal sign. So when I square a square root, the square root box goes away, and I've got x equals, and then I'm going to do 16 times 16. So x equals 256. And that is my answer. So with number 4, I do have a radical on each side of the equal sign, and they're completely isolated. So I will square both sides of the equal sign. So when you square a square root, the square root box goes away. When you square a square root box goes away. I need to solve for x, so I'm going to do minus x on both sides of the equal sign. And when I do that, I get -7 equals +3, which is not possible, so this is no solution. On number 5, I have a radical on each side of the equal sign, and they're both isolated. So I can square both sides. So when I square a square root, the square root box goes away. When I square a square root box goes away. And now I'm ready to solve. So I'm going to do minus 5v on both sides of the equal sign. So 7v minus 5v is 2v. Minus 10 equals 10. And then I'm going to add 10 to both sides of the equal sign. And I have 2v equals 20. And then we will divide by 2, divide by 2. V equals 10. Okay, on number 6, again, I have two radicals. They are already isolated. So I can square both sides. So when you square a square root, so that is s plus 7 equals, and then 11 minus s. So to solve for s, I'm going to add s to both sides of the equal sign. So 1s plus 1s is 2s plus 7 equals 11. Then I'm going to subtract 7 on both sides. So 2s equals 4. Divide by 2, divide by 2, and s equals 2. Okay, the last two are story problems. The formula t equals square root of n over 16 gives the time t in seconds for an object to fall that is initially at rest to fall in feet. What is the distance an object falls in the first, and we'll go with 15 seconds. So what we're going to do is, I'm going to do my work over to the side here. We're going to do t equals square root of n over 16. And then remember that our t was time, and we were given a time. So we're going to put 15 in for t equals square root of n over 16. Now I have my radical isolated, so I can square both sides. So 15 times 15 is 225. And when you square a square root, the square root box goes away. And now I want to get n all by itself. So I need to multiply both sides by 16 over 1 so that that will cancel and that will cancel. And I have n equals, and then I'm just going to do 16 times 225, 3,600. And number 8 is just like our number 7. The formula T equals square root of n over 16 gives the time t in seconds for an object that is initially at rest to fall in feet. What is the distance an object falls in the first 9 seconds? So again, I'm going to come over here to the side. T equals square root n over 16. I'm going to replace the t with 9. My radical is isolated, so I can square both sides of the equal sign. So 9 times 9 is 81. And then when you square a square root, you get rid of the square root box. Then to get rid of that 16 on the bottom of that fraction, we're going to multiply by 16. That gets rid of our 16 on bottom, 16 on top, and leaves us with n. And then we're going to do 16 times 81, and we're going to get 1,296.